In part 2 of the Unit 2 notes, we will be covering physical versus chemical changes. A physical change is a change to a sample of matter in which some properties change, but the identity of the matter does not. This may be reversible or irreversible. So a couple of examples of this, we could consider breaking glass. So when I have a sheet of glass and I break it up into smaller shards, it's definitely going to look different, but it still has the same exact chemical composition that it had before. So that would be a physical change. Grinding down a rock. So I could start with a large rock like this and grind it down into a fine sand, but it's still going to have the same exact chemical composition throughout the entire process. If I start off with two separate bags of blue and white marbles, and then I mix them together into a single container, they are also going to be the same exact marbles that they were before. They're just going to be mixed. The next two are ones that are often mixed up: dissolving sugar in water and changing phase. Now, when you dissolve sugar in water, it appears that the sugar kind of disappears within the structure of the water. But if you were to evaporate the water away, the sugar would still be present there. So while it has dissolved, the chemical composition of that sugar hasn't changed. So it's going to be a physical change. As I go from ice to water to steam and then transition all the way back again, throughout that entire process, the substance is still H2O. So that is also an example of a physical change. I could take a can and crush it to make it a lot smaller. I could mix sand with water, shred paper, or chop a piece of wood. And all of these would be examples of where the substance didn't really change on a molecular level. All right, next up, chemical changes. A chemical change is a process that occurs when one or more substances are changed into one or more new substances. So this is something that's actually occurring on the atomic level. A good example of this would be burning wood. So we end up with ash. There's energy which is being given off throughout that process. And the original components that were there in the beginning, the log itself, is no longer present in the end. Anytime you are cooking or baking, that is going to be a chemical process that is going to occur. You're going to have color changes in texture, potentially gases which are being emitted. The rusting of a metal, that is going to be another example of a chemical change. Also, color changes in texture. If we're talking specifically about rust, you have iron, Fe, which is changing into iron oxide, Fe2O3. So you're ending up with a different chemical compound in the end. Digesting food. You're taking food such as, say, a hamburger, and you're breaking it down into smaller chemical compounds which your body could potentially use for energy. So that is going to be a chemical process. Decaying or rotting organic matter. So when you have, say, a leaf which goes from green to yellow to orange to brown, that is going to be a chemical process as the chemicals inside of the leaf are decaying, specifically the chlorophyll in that example. And then finally, decomposing chemicals. So if I have a chemical like hydrogen peroxide, for example, H2O2, and it's decomposing or breaking down into other things like water and oxygen gas, which is the process that's actually occurring in this picture right here for elephant toothpaste. That is going to be a chemical process that's occurring. You have new compounds or elements in the end. Now let's take a look at a few examples for how you could tell that a chemical or a physical process is going to be occurring by just using observations. If you see a color change which is not the result of mixing colors. So for example, I take a clear solution and another clear solution and I mix them together and it turns purple. There's no real reason why that substance should turn purple. That means that there must be some kind of chemical process that's occurring there which is leading to that color change. But for example, if I mix blue and white and I get a light blue, well, that's just mixing colors. That would be a physical change that's occurring. So a color change is not always indicative of a chemical change, but it certainly could be a factor to help you determine that one has occurred. So you kind of have to think about the colors that you started with and what you ended with, and if they made sense if you were just mixing. All right, our second piece of evidence is precipitate formation. Now, in this context, a precipitate, it doesn't mean precipitation. We're not talking about rain here. We're talking about a solid which is going to fall or crash out of solution when you have two solutions that are mixed. So you can see from our picture here, we started with two clear solutions, but when they're mixed together, we create this new substance which is no longer soluble. It can't stay within that structure of the water. So it forms these little yellow crystals that will eventually settle down to the bottom of this beaker, and it'll be kind of like sand, so it'll settle down to the bottom. So if you form a precipitate, that means a chemical change has occurred. Gas production. The gas produced is not the result of a phase change. So if I have liquid water, I put it on a stove and I start heating it and it reaches 212 Fahrenheit or 100 degrees Celsius. That's a phase change. That is going from liquid water into gaseous water or steam, and that's to be expected. But if I mix two chemicals at room temperature and neither one boils at room temperature and I start seeing a gas come off, that means that a chemical reaction is occurring. So that's what you see in this picture here. We have this liquid and the solid that are mixed together, and then you end up with bubbles. A temperature change. If heat is either absorbed or released. So here we can see this chemical reaction which is occurring, which is giving off a flame. So there's a lot of light and heat which is being emitted here, which is actually connected to our next one, emission of light. Often these two will potentially occur together. So energy is emitted in the form of light. You could see that if you had any kind of glow necklace or a glow stick. So you crack a tablet inside of that substance which mixes two chemicals, and then you have the emission of light occurring because of that chemical reaction. So if we're doing a lab and you are making observations and you see any of these things, that could potentially show you that a chemical reaction is occurring. All right, for our checkpoint, in this video, we are going to be looking at identifying whether or not a change is chemical or physical. And when you're doing this, you really want to look at the key action word. So the first example here, we have evaporation of alcohol. The alcohol part of this is actually irrelevant. It could say evaporation of gasoline or evaporation of water. The key here is evaporation. Evaporation tells you that you are going from a liquid to a gaseous state, but the actual matter itself is not changing on the molecular level. If we're talking about water, it's H2O throughout that entire process, and the same would be true for the alcohol here. So this is going to be a physical change. Now, rusting of a bicycle. This one I mentioned before. We have iron, which is Fe. You're adding oxygen, and you end up with Fe2O3, which is rust. So it's actually changing on a molecular level. You have a new color, a new texture. So this is going to be an example of a chemical change. Digestion of a sandwich. We also mentioned digestion on the previous slide. That sandwich is being broken down into smaller compounds, which could then be used by your body as energy. So that sandwich is no longer a sandwich in the end, so that is definitely going to be a chemical reaction. And finally, sugar dissolving within water. Doesn't matter if it's sugar, salt, or any other substance. The fact that it is dissolving is important. So if you are dissolving one substance into another, that is going to be a physical process. By evaporating away the water, you would get that substance back in the end. That concludes part 2 of our Unit 2 notes. When we come back for part 3, we're going to be looking at classification of matter.